Welcome to this explainer. Look, today we're jumping right in, taking an urgent, totally numbers-first look at a massive financial leak that's just hiding in plain sight inside daily paper mill operations. We aren't just talking about profitability in some abstract way here. No, we are talking about hard math, daily cash losses, and the highly specific software engineered to finally stop the bleeding.
Let me hit you with a hook right away. Imagine you're running a standard, mid-sized mill producing 30 metric tons a day, and you're buying pulp at, say, 60,000 rupees per metric ton. A 10% trim waste, which, by the way, is completely typical, equals this exact, undeniable financial loss, 1,80,000 rupees.
That's right, 1.8 lakh walking right out the door every single day. This isn't just some one-off machine failure or a bad quarter we're talking about. This is a relentless compounding profit bleed happening with every single production run. It's totally silent, it's widely accepted as just normal, and frankly, it is absolutely devastating to your bottom line.
Now, according to the Central Pulp and Paper Research Institute, there are exactly 526 operational paper mills in India right now, and the vast majority of them, they are just hemorrhaging margins because they fundamentally misunderstand the problem. They treat trim waste as a manufacturing quality issue or just an unavoidable byproduct of doing business. But it isn't. It's actually a math problem.
Okay, let's dive into this. The traditional method is manual deckle planning. We're talking about highly skilled plant head standing in front of whiteboards or staring at massive Excel spreadsheets trying to manually puzzle together hundreds of order combinations. But the reality is, deckle planning is a massive combinatorial math problem. Your human brain, even with a really big whiteboard, just cannot optimize those variables perfectly. And because of this manual planning limitation, trim waste in Indian paper mills runs anywhere from 8 to 15% on average. When you're relying on manual methods to solve hundreds of overlapping order combinations, differing GSMs, highly specific customer widths, strict machine constraints, the human brain inevitably defaults to the easiest path, not the mathematically optimal one. And the direct result? You overorder pulp, you underfill your parent reels, and you literally throw away margin right there on the cutting floor. Which brings us to the solution, the Papyrus Deckle Optimizer. Now, this isn't just some basic calculator. It is powered by MILP, or Mixed Integer Linear Programming. This is literally the exact same advanced mathematical optimization algorithm used by the aerospace and global logistics industries to perfectly map out flight paths and complex shipping routes. Papyrus has basically taken this hardcore multi-tier optimization and applied it specifically to paper mill deckle planning. It evaluates every single possible cutting combination in mere seconds.
And hey, the numbers back this up entirely. According to a 2020 study published in Applied Sciences by MDPI, mathematical optimization proves that a trim loss of just 2.2% is highly achievable. I mean, let that sink in for a second. Compared to the 8 to 15% industry average, the Papyrus Deckle Optimizer routinely reduces trim by 5 to 15% on average compared to your manual planning baseline.
Let's move to and see how this builds, because the workflow is incredibly fast. Step 1. Input. The system just takes your pending customer orders, including GSM, deckle width, and quantity. Step 2. Constraints. It automatically factors in your machine's specific rules, like reel width, minimum run length, and grade changeovers. Step 3. Output. In literally seconds, the solver generates the absolute, mathematically optimal cutting plan before you ever even confirm the run.
Crucially, this isn't some isolated tool requiring tedious manual data entry. It's fully integrated. It automatically pulls directly from your live sales orders. No spreadsheet exports, no manual re-entry, which means you completely eliminate the typical transcription mistakes that just plague manual planning. And this brilliantly illustrates that the optimization logic actually extends way beyond just trim waste. It acts as a total operational powerhouse. It minimizes grade changeovers to significantly reduce machine downtime. It maximizes reel utilization so you have way fewer partial reels, and it intelligently consolidates small orders. Plus, if you run a multi-machine mill, it even optimizes across Paper Machine 1 and Paper Machine 2 simultaneously.
It's also definitely worth noting that this aerospace-grade logic isn't strictly for full-scale paper manufacturers. Paper traders who are buying parent reels and doing converting operations can use this exact same mathematical logic to seamlessly plan slitting cuts and perfectly minimize those frustrating offcuts against their own customer orders.
Now, what's really interesting about this slide is that it grounds everything in a tangible daily reality for mill owners. We're going to look at the hard math for a mill running just 3 production batches per day.
Look at the stark contrast here. Relying on whiteboards and Excel, average trim waste sits at 9.8%. But with the Milpy solver deployed, that trim waste plummets to 2.7%. That difference is pure pulp, expensive energy, and labor that you are quite literally currently throwing straight into the repulsor.
So the crucial point is the cash. That single reduction in trim translates to a hard cash savings of exactly 37,800 rupees per single batch. That is real money that stays in your business instead of just becoming waste.
Now let's escalate that math a bit. You run 3 batches a day. Over the course of a year, that 37,800 rupees per batch compounds into a massive 4.1 crore rupees in pure top-line annual savings. That is over 4 crores, found hidden right inside your existing operations, simply by letting an algorithm do the math instead of a human.
And here is the cost of the software that actually generates that 4.1 crore in savings. Just 7.2 lakh rupees per year. That is the stark contrast right there. You are looking at a very minimal annual software fee to plug an absolute multi-crore hole in your daily operations.
Which brings us to the ultimate mathematical punchline. The payback period for the Papyrus Deckle Optimizer is a staggering 3 weeks. Yeah, in less than a month, the software has paid for itself entirely. And for the rest of the year, it delivers a massive 40x return on investment. 40x!
Thanks so much for joining me for this explainer. If you're ready to turn your mill's daily trim loss into actual crores saved, you've got to book a demo and implement the math, because I really want to leave you with this final provocative thought. Every single day you allow your team to plan decals manually, why are you actively choosing to pay for trim you didn't even have to produce?